Hey everyone, welcome to What If? We're glad to have you with us here today. On today's episode, well, it's a fun one, but it's a bit of a marathon of despair. We're going to take you through the top 10 ways that life on Earth could come to an end. But don't worry, none of them are going to happen to us. And none of them will be fun, but rest assured, you and I will have some fun learning about them. That's what we do here. So first off, what would happen if Earth pulled the emergency brake? Would we all just get a bad case of whiplash? You wish.
Hang on, because we're about to screech to a halt. That's right, the Earth is going to stop spinning for 5 seconds. How much damage would this sudden stop cause? What would you experience in different parts of the world? And when the Earth starts spinning again, would it still be habitable? This is What If, and here's what would happen if the Earth stopped spinning for 5 seconds. The Earth makes one full rotation on its axis in one day. This gives us day and night. The Earth is spinning because of collisions that happened when the planet was forming 4.6 billion years ago. As a huge disk of gas and dust swirled around the sun, dust and rock grains clumped together, generating forces that kept the planet rotating in one direction. You could imagine it much like a figure skater spinning faster and faster. And with almost no forces in space to slow the planet down, we keep rotating, and will continue to for billions of years. But if the Earth stopped on a dime, would you fly right off the surface? If the planet came to an abrupt halt, the atmosphere would still be in motion. That means, though everything has lurched to a stop, powerful winds would continue to blow. And these wouldn't be a strong breeze. They would be many times stronger than any storm you've ever encountered. Now, the strength of these winds would differ based on where you were on the planet. At or near the equator, the Earth is rotating the fastest. Here, you'd experience wind speeds of 1,670 kilometers per hour. Those winds would knock you off your feet. But forget about you. These winds would be strong enough to tear up the Earth's crust. So it wouldn't matter if you were out in an open field or inside a steel-reinforced building. These winds would obliterate you. For context, the strongest F5 tornadoes have velocities up to 511 kilometers per hour. And these storms can move houses off their foundations, send cars flying, and even tear apart concrete structures. The winds from the Earth's emergency brake would be 3 times stronger than that. So if the crust under your feet didn't crumble, you and a lot of other stuff would likely go flying a great distance. But not off the face of the Earth. The escape velocity, or the speed you need to escape the Earth's gravitational forces and enter space, is about 40,000 kilometers per hour. In other parts of the world, like New Zealand or France, you'd experience slightly weaker winds, but at 1,180 kilometers per hour, these would still be much stronger than any storm ever. These winds would pretty much destroy everything, but they wouldn't be the only hazard you'd need to keep an eye out for in these short 5 seconds. Our planet is not a perfect sphere. It bulges near the equator due to the centrifugal forces generated by the planet's rotation. If the rotation stopped, the Earth would transform quickly into a perfect sphere. All the water gathering near the equator would flow away toward the poles, generating a massive tsunami. 5 seconds later, when the planet returned to its full-speed rotation, that water would backtrack. a wall of water would slam into everything and everyone twice. That's one heck of a storm. Maybe the only place you'd be safe in this scenario is near the North or South Poles. Here, the wind would be the mildest. Now, you must be relieved to hear that the Earth has returned to its normal rotation after all this, but like I said, there would be nothing left on it. Every building, all farmland, and all technology would be demolished beyond recognition. Billions of people, if not every single person on Earth, would die from the brute force of being slammed by the massive gusts of wind. So, if you're looking to survive this apocalyptic scenario, you'd better start building an underground bunker. Luckily, it's expected the Earth won't come to a halt anytime in the next few billion years.
Some of these events can be pretty scary, especially when it comes to our changing climate. But luckily, I have some good news for a change. Yeah, the Biden-Harris administration is making significant steps to protect the Arctic National Wildlife Reserve, as well as 13 million acres of the National Petroleum Reserve in Alaska. The Bureau of Land Management is also putting in new regulations to ensure the maximum protection for these 13 million acres. This helps preserve the wildlife, protect the environment, and helps support the native Alaskan communities. And that's not all. They're also in the process of canceling the remaining 7 oil and gas leases that were issued by the Trump administration. All these initiatives are helping ensure that the United States Arctic Ocean is off limits to new oil and gas leasing. This helps protect millions of acres, both on land and on the water, which in turn helps all the animals within the ecosystem and helps push back against our warming climate. The more initiatives our leaders can act on, the better our chances will be in the fight against climate change. So let's keep spreading the good news and pushing our leaders for progress.
An asteroid is headed straight toward Earth. Initially, scientists thought it would miss us, but they've made some serious miscalculations. And now it's headed right toward our giant blue marble. What happens next? Does this mean the end of humanity? Can we change the trajectory of the asteroid? And why might this actually happen by the year 2029? This is What If, and here's what would happen if an asteroid hits Earth this year. Now, this sounds like a fun hypothetical, but an asteroid coming for Earth? It's no laughing matter. It could happen. Scientists had thought that asteroid 99942, also known as Apophis, might hit Earth by the year 2029. Apophis was discovered in 2004, and scientists have been closely monitoring it ever since. At one point, research suggested that the asteroid had a 2.7% chance of hitting Earth. Yeah, scary, I know, but since then, new calculations predict that the asteroid will whiz by Earth at a distance of 30,000 kilometers. Now, considering that the moon is 380,000 kilometers away, this asteroid will be incredibly close. But at least it won't be hitting us. And of course, calculations can be wrong. Let's say that in this case, they are, and Apophis is coming right toward Earth. Way ahead of schedule. The asteroid is going to hit us this year. Okay, let's see what we're dealing with. Apophis is 340 meters in diameter. For reference, that's taller than the Eiffel Tower. But is it the worst asteroid Earth has ever seen? Nah, lucky for us, it's not even close. The Chicxulub asteroid that wiped out the dinosaurs was estimated to be 10 to 15 kilometers wide. So now we're dealing with Chicxulub's little brother. So what does that mean for us? Will humans go extinct from this impact? Well, more on that in a bit, but first, let's look at whether we have any chance of stopping this asteroid.
Okay, the first step would be identifying the asteroid, which we've already done. We know how big Apophis is and that it's moving at about 30 kilometers per second. Now it's about the defense measures we could use. There's a couple being looked into right now. One of them being the kinetic impactor. This involves sending a spacecraft to collide with the asteroid, all in hopes of changing its velocity and trajectory. NASA has run some successful tests using this method, so that's an option. Next would be what's known as a gravity tractor. A large spacecraft would fly next to the asteroid, and over time, its gravitational pull would eventually change the asteroid's path. Laser ablation is next on the list of options. Yeah, special lasers could be used to vaporize parts of the asteroid's surface. This wouldn't destroy the asteroid, but it could alter its direction as well as the size and impact of it. And last but definitely not least is the final nuclear option. Yeah, that's right. As a final resort, we could nuke Apophis. And with the asteroid's massive size, as well as the lack of time we have before it hits us, this might be the only option. But don't be too quick to hit that red button. Nuking an asteroid can have some serious downsides. It could split the asteroid up, causing it to fragment. Then you'd have dozens more minor asteroids and meteors coming toward Earth, making the impact even more devastating. Yeah, and these wouldn't just be regular asteroids either. Because of the nuke, they'd be radioactive. This would mean that significant parts of the world would not only be impacted with asteroids and meteors, but they'd also experience radiation levels only seen during nuclear warfare. So, what's the best option here? Well, it's tough to decide. Let me think about this for a second. Oh, well, it's too late now. We took too long deciding what to do, and now the Apophis will be here any second. Brace yourselves. You wouldn't get a good look at the asteroid impact, and that's because it landed somewhere in the middle of the Pacific Ocean. This is the most probable spot an asteroid would land, considering the Earth's surface is mostly water. So you might not see the impact, but you definitely notice it. Once the asteroid hit our planet, it would be as devastating as several thousand nuclear bombs going off, just with a lot less radiation. It would make a crater at the bottom of the ocean as big as a kilometer wide. And what would happen next would be even more devastating. The massive impact would create giant tsunamis that would rage worldwide. Several hours after the asteroid touches down, cities along the Pacific coast would feel Apophis's impact. The tsunamis would travel across the Pacific Ocean at jetliner speeds. Places in North and South America like California, Peru, and Chile would face towering waves. Due to the energy from the asteroid, it would likely cause waves taller than 30 meters. Waves as big as this are responsible for one of the most devastating tsunamis ever. In 2004, Southeast Asia experienced a tsunami that generated waves over 30 meters tall, killing over 230,000 people. But instead of waves like these reaching just a few countries, this would be a complete global catastrophe. Not only would the Americas experience these tsunamis, but so would Japan, Australia, and the Philippines. These places would all be devastated by the impact. Tsunamis like these would likely destroy millions of lives. So that's what would happen if an asteroid hit the ocean, but what if it made impact on land? Well, to start, the impact crater would be much more significant. We know that an asteroid's impact crater can be anywhere from 10 to 20 times the size of the asteroid itself. And now there isn't any water to soften the blow, so the diameter of the crater could be as large as 7 kilometers, with a depth of over 1 kilometer. Depending on where it lands,
this asteroid could be big enough to devastate entire cities. The initial impact would send a massive shockwave that spreads for hundreds of kilometers. This could destroy entire buildings and seriously damage infrastructure. It would throw tons of dust and debris into the atmosphere. It could get so bad that it could cause an impact winter. This would be caused by a dust cloud temporarily blocking the sun, causing crops and vegetation to die out, which creates even more casualties. Something like this could last weeks or months and be an overall environmental catastrophe. This entire event, during and after, could cause millions of people to be killed, depending on where the asteroid lands. We can only hope that an asteroid collision like this would land as far away from people as possible. But now for the good news. If Apophis did somehow make an impact, it wouldn't cause a mass extinction like the Chicxulub asteroid did for the dinosaurs. The event would be incredibly traumatic and have lots of casualties, but humanity as a whole would live to see another day.
Cool. So some of us live to face another certain death scenario. Another day. Face another day. Now, coming up later in the show, we'll take a look at some other giant asteroids that could hit Earth, like Ceres, the largest object in the asteroid belt. Okay, ever been afraid of being hoovered up by a big black hole? Well, this next one will let you know what it's like. And spoiler alert, it's no good. What'd you think it would be?
Could a black hole devour us all one day? There are millions of them out there, just waiting. And if we happened to make a black hole accidentally, well, you better fasten your seatbelts. Things are really going to suck. Literally. What would we see if we got pulled into a black hole? Could Earth orbit the sun and a black hole? And would we survive spaghettification? This is What If, and here's what would happen if Earth were sucked into a black hole. Just 3,000 light years from Earth is a black hole visible to the naked eye. Thankfully, we're a safe distance from this stellar black hole and many others like it. There are approximately 100 million of them out there in our galaxy that we know of. They are remnants of supernovae, which occur when stars 10 to 20 times larger than our sun collapse in on themselves. Stellar black holes are fairly common and are about 16 kilometers in diameter. And then there's the much larger competition. Supermassive black holes. These have a diameter roughly the size of our solar system and a mass greater than 1 million suns combined. One of them, known as Sagittarius A, is right smack dab in the middle of our galaxy. So, how close would a black hole need to be a danger to us? Well, technically, a black hole the size of a 1 millimeter pin could destroy us if it was close enough to Earth due to its incredibly dense mass and extreme gravitational pull. Our survival all depends on whether we've surpassed the event horizon or not. You can think of this as the black hole's point of no return. Anything beyond this point would have to travel faster than light to escape. Yeah, good luck with that. If Earth got close enough, the side nearest to the black hole would begin stretching toward it. Our atmosphere would start to be vacuumed up, and then huge chunks of the Earth would rip apart and follow suit. If Earth managed to fall into the orbit of the black hole, we'd experience tidal heating. The strong, uneven gravitational pull on Earth would continuously deform the planet. This would generate a tremendous amount of internal friction, heating the Earth's core to disastrous levels. It would likely give rise to earthquakes, volcanoes, and deadly tsunamis. The trifecta of doom. Eventually, Earth would begin to stretch in a process known as spaghettification. And not in the tasty, cheesy, tomatoey way.
Mamma mia!
Let's say you were a superhero and decided to fight the black hole head first. Well, your arms would be closer than your feet, causing your body to stretch out vertically and become more and more compressed. Let's hope your superpower is elasticity. For an average-sized stellar black hole, spaghettification could occur several hundred kilometers away from the event horizon. But for a supermassive black hole, physicists believe that this would happen inside the event horizon due to its size. Eventually, no matter what size it is, anything entering a black hole would be ripped into a string of individual atoms. This would happen to anything that crosses it. People, planets, stars, you name it. Unfortunately, our whole solar system would be doomed. The careful balance of the sun and our many planets would collapse, which could send them crashing into one another. And to add insult to injury, our asteroid belt would get sucked toward us. About 200 of the 552,894 asteroids we know of are more than 100 kilometers across. So, if one hits us, we'd be dead before we would turn into spaghetti. Frankly, I'm not sure which fate would be worse. All of the matter in our solar system would join the accretion disk around the black hole. As matter gets sucked into the black hole, it generates massive amounts of radiation, so even if we somehow survived all the asteroids, we'd likely die from the radiation. Believe it or not, astronomers have discovered rare circumbinary planets that orbit two stars. While this may be a possibility with a black hole and our sun, the extreme tidal forces would likely make our planet uninhabitable. And worse yet, we might get kicked out of orbit or swallowed by the sun or the black hole eventually. Sorry, but there's not an outcome where we win here. But, and this is a big but, maybe we could find a way to protect ourselves in some hyper-reinforced space shuttle. If we somehow made it past the event horizon, we might be in for an even stranger time. Physics as we know it would change. Things like gravity, the speed of light, and even how atoms bind and react may be completely different. The truth is, we don't know what would happen. We can't get any information out of a black hole. Would we get pulled into another dimension? End up in a parallel universe? Or maybe we're already inside a black hole. Would you sleep in this earthquake-proof bed? It senses when an earthquake is happening and drops you into a safe metal chamber. Yeah, we know how ridiculous this looks. But desperate times call for desperate measures. Because we're about to experience the most powerful earthquake in history. A magnitude 20. How much damage would it cause? Would it break our planet into pieces? And what could cause such a massive earthquake? This is What If, and here's what would happen if a magnitude 20 earthquake hits. To understand just how big a magnitude 20 earthquake would be, let's take a look at the Richter scale. The Richter scale is a logarithmic scale that rates the amount of energy released by an earthquake. What does logarithmic mean? Well, in this case, it means that the amount of energy released increases 31.7 times between whole number values on the scale. For example, a 2.0 quake is 32 times as energetic as a 1.0 event. And a 3.0 quake is 1,000 times more powerful than a 1.0 event. The largest earthquake ever recorded registered a magnitude of 9.5, and it caused about $5 billion in damage. It killed 1,655 people and left 2 million people homeless. So, how much worse would a magnitude 20 be? Would we have to evacuate the planet? To properly prepare for an earthquake this big, we need to understand what causes earthquakes in general. Earthquakes are vibrations that travel through the crust of the Earth. They can be caused by events like volcanic eruptions and meteor impacts, but the movement of tectonic plates is what usually causes them. These plates, which make up the Earth's crust, can slide against each other at a region called the transform boundary. When the plates move in different directions, they can cause a break in the Earth's crust called a fault line. This is where most earthquakes take place. The plates create friction as they push together tightly. And if there's enough friction, they can become locked together and stop sliding. But the forces of the Earth will continue to push against them and increase the pent-up energy and pressure. When the pressure builds up enough, it will overcome the friction and result in an intense and sudden shift. This causes the vibration we know as an earthquake, and the longer the fault line, the more massive the earthquake. So, how long of a fault line would be required to produce a magnitude 20 earthquake? Well, let's put it this way. To produce a magnitude 10.5 earthquake, you'd need a fault line of about 80,000 kilometers. And given that the Earth's circumference is only about 40,000 kilometers, that would be highly unlikely. With all that considered, a magnitude 20 earthquake seems pretty impossible. So there's nothing to worry about. Oh right, except for that. One way that a magnitude 20 earthquake could occur would be due to a massive asteroid impact. An earthquake this large would last longer than any earthquake we've ever experienced. You would feel the shaking for at least 5 minutes, and aftershocks would go on for hours. Tsunamis and volcanic eruptions would be taking place. More earthquakes would likely be triggered, and the whole world would be falling apart. Literally. For the power of this earthquake to destroy the planet, it would need to overcome something called the gravitational binding energy, which describes the minimum value a spherical and uniform object needs to keep together under the influence of gravity. Now, we won't go into specific values here because we don't want to make things any more complicated, so we'll leave it at this. We're screwed. A magnitude 20 earthquake would produce more than enough energy to overcome the gravitational binding energy and destroy our planet. But the good news is that we would likely see the massive asteroid coming and would have time to prepare for everything that comes with it.
Okay, coming up in a few minutes, we'll take a look at a few of the most massive asteroids we know of and what it would be like if they crashed into Earth. But first, our planet has been experiencing some devastating natural disasters over the past few years, from massive floods to ruthless earthquakes to devastating forest fires. Now, one thing we haven't experienced, at least not for the last 165 years, is a massive solar storm.
Bursts of solar flares from the sun's surface look spectacular, but they can pose a danger to us here on Earth. If one was to hit us hard enough, it would knock our entire planet into darkness. Wait, what? How can the sun do that to us from a distance of 150 million kilometers away? And what could you do if that happened tomorrow?
This is What If, and here's what would happen if a massive solar storm hit the Earth. It wouldn't be the solar flares that sent us back into the pre-technological era. It'd be the giant clouds of hot plasma and electromagnetic radiation that the sun spews out. This is a phenomenon known as a coronal mass ejection, or CME. In 2012, a powerful CME shot through the Earth's orbit. Luckily, we missed a direct hit. We weren't so lucky back in 1859, when the electromagnetic radiation of another CME set telegraph pylons on fire. The telegraph. That's really all there was for technology at the time. But now, our entire planet is deeply reliant on electricity and electronics. If a solar storm that strong were to strike today, we'd be in a much worse situation. It would start with an enormous explosion on the sun's surface. The solar flare would zap the Earth's upper atmosphere with a giant electromagnetic pulse. This would block radio signals between the Earth and our orbiting satellites, but it wouldn't damage them just yet. Not until minutes to hours later, when a stream of charged particles started bombarding the Earth's magnetosphere. These particles would hit some of the satellites and damage their electronics. Our communication systems would begin failing. But the worst is yet to come. After anywhere from 12 hours to several days, a cloud of plasma would finally reach the Earth. First, it would hit NASA's ACE satellite, designed to warn us about the upcoming storm. Even with that warning, we'd only have about 30 minutes before that space cloud rained down on our magnetosphere and triggered a geomagnetic storm here on Earth. Hopefully you're not in an airplane at the time, because its GPS system would fail, and your pilot would have to start navigating without it. On Earth, the geomagnetic storm would start to melt our power grid transformers. Do you know what that means? A global power outage. Not much fun for all us power-hungry humans down here. All the lights would go out. You wouldn't be able to charge your phone or your laptop. Your fridge would stop refrigerating, and your heater would stop heating you up. Make sure you have some spare cash, because all the ATMs would be useless, just like your credit cards. Most likely, you wouldn't even be able to flush your toilet, since in most modern cities, water supply is controlled electronically. Anything and everything relying on the internet would shut down. No banking services, no internet access in the transportation system, and no social media to vent your frustration in. We can't control the space weather. If the sun were to send us a direct hit, this hypothetical scenario would get real. Almost real. NASA and the Space Weather Prediction Center keep monitoring the activity of our sun. Their 3-day forecast would give us a heads up if our star looked suspicious.
Absolute zero is the lowest possible temperature in the universe. Nothing gets colder than that. So, if the entire Earth suddenly cooled down to the most frigid temperature for even 5 seconds, it would wreak a lot of havoc. Just how cold is absolute zero? What would happen to your body at this temperature? And what's the coolest thing about it? This is What If, and here's what would happen if the Earth dropped to absolute zero for 5 seconds. Temperature is how we measure kinetic energy of the particles in any object. Yeah, it tells us how fast atoms, molecules, and particles move. The hotter a gas, liquid, or solid gets, the faster the particles move. And when that movement slows down, the colder that substance becomes. At the lowest temperature possible, or absolute zero, particles stop moving altogether. This is because at 0 Kelvin, or minus 273.15 degrees Celsius, no heat energy remains. The coldest ground temperature ever on Earth, 184 Kelvin, or minus 89.2 degrees Celsius, was recorded in Antarctica in 1983, but it doesn't even come close to absolute zero. Even the coldest known place in the entire universe, the Boomerang Nebula, 5,000 light years away from Earth, is just a tad warmer at 1 Kelvin. So, are you ready for the coldest 5 seconds ever? At room temperature, that comfortable range of temperatures of about 293 Kelvin, the air molecules move at an average speed of 1,800 kilometers per hour. As the temperatures on Earth suddenly plummeted, all those particles would slow down. At 0.00001 Kelvin, the atomic particles would be moving at a speed of about 0.18 kilometers per hour. That's 1,000 times slower than their speed at room temperature. Getting this close to absolute zero, all chemical reactions would be closer and closer to coming to a complete stop. And this would be very bad news for you and everything else on Earth. Chemical reactions are responsible for everything, including how your brain communicates with your body. Without the trillions of chemical reactions going on inside of you, you wouldn't be able to breathe or turn food into fuel. Temperatures near absolute zero would be devastatingly cold. Even at a comparatively toasty 77 Kelvin, you'd be in serious trouble. That's the temperature of liquid nitrogen. After just a few seconds of exposure to this temperature, you'd suffer severe burns, blistering, and frostbite. Needing a toe or 10 amputated could be a definite possibility. So, just 5 seconds of absolute zero could do incredible amounts of damage to all life forms on Earth. But I have good news. The chemical reactions wouldn't come to a total standstill. Even at the near absolute zero temperature of the Boomerang Nebula, chemical reactions do still appear to take place. This is thanks to the strange effects of quantum physics. And whenever quantum physics is involved, things get weird. With all the atoms on Earth at a near standstill, you'd find them starting to clump together. They'd be forming a state of matter known as a Bose-Einstein condensate. This would mean that every atom is in the same energy state and essentially identical to one another from a physical point of view. They'd start to behave as a single atom. And if you could become a Bose-Einstein condensate, it would be pretty cool, pardon the pun. For those brief 5 seconds, you'd have some unique physical properties, like superfluidity. Yeah, you'd be able to flow through tiny cracks without any friction. Only there wouldn't be any cracks because you wouldn't be the only superfluid thing on the planet. But there is a catch. Bose-Einstein condensates can only be formed when bosons are cooled to near absolute zero. Bosons are all atoms with an even number of electrons. That means only some of the atoms in your body and the environment around you could become a Bose-Einstein condensate. And lucky for you, reaching a temperature of absolute zero wouldn't be possible. If Earth and everything on it plummeted to absolute zero, it would instantly pull the heat from the space around it. To keep you and the planet at 0 degrees Kelvin, even for 5 seconds, you'd need an infinite amount of resources. This makes it mathematically impossible. But that wouldn't mean that 5 seconds of near absolute zero temperatures wouldn't destroy just about everything. And nothing would ever come back together from this soup of atoms that you and the entire planet would turn into.
So, Again, like with every other one of our videos today, it's not likely to happen, but if it did, right? That's why What If is so interesting. We get to investigate so many devastating events and find out the science behind them, but never actually have to live through them or die through them. Okay, as promised, let's have a look at 6 of the largest asteroids. This is 6 of the largest asteroids we know of, and what the consequences would be if any of them or all of them hit us.
Whoa, watch your head. Some seriously big asteroids are crashing into Earth. What kind of shapes and sizes do they have? Which ones would have the deadliest impact? And which one would be most likely to hit us? Uh-oh, get your bunker ready. This is What If, and here's what would happen if the largest asteroid hit Earth. Okay, let's get the terminology out of the way. I say asteroids, but some of the objects on our list are not asteroids. They're comets. Both asteroids and comets are objects in our solar system, but they aren't the same. Asteroids are rocky leftovers from the early formation of our planetary neighborhood. And of the over 1 million that we know of, most orbit the Sun in the asteroid belt between Mars and Jupiter. On the other hand, comets are snowballs made of frozen gases, rock, and dust. They orbit the Sun, and when they get too close, they start to melt. This releases a giant cloud of dust and gas that can be larger than most planets. With 3,000 known comets in the solar system, could a few be ready to turn the Earth into a giant cloud of dust too? Chelyabinsk meteorite. Let's start with a smaller object that has already hit our planet. Meet the Chelyabinsk meteorite. It exploded over Russia in February of 2013. With a diameter of about 17 meters, it was relatively small, but the impact was huge. The explosion had the energetic equivalent of 500,000 tons of TNT. That's about 30 times as powerful as the bomb that was dropped on Hiroshima. It injured 1,200 people and caused enormous property damage. Pretty big effects from a little extraterrestrial visitor. Chicxulub. Moving on to something bigger, we'll go 65 million years into the past. The massive Chicxulub asteroid was likely one of the forces that resulted in the mass extinction of the dinosaurs. It was about 10 to 15 kilometers wide, and its impact crater in Mexico's Yucatan Peninsula measures 180 kilometers wide and 900 meters deep. Whoa! When this asteroid slammed into Earth, it devastated everything nearby. The blast wave sent enormous amounts of rocky material into the atmosphere, and it caused tsunamis as high as 1,500 meters. While all the soot didn't completely block out the sun, it reduced the amount of sunlight reaching the surface of our planet. That seriously devastated plant growth and had rippling consequences on the food chain. Eventually, it caused entire ecosystems to collapse. Oumuamua. Of all the objects that could collide with us, Oumuamua has one of the more interesting shapes. This rocky, cigar-shaped object is about 400 meters in length. NASA classifies it as a comet, but it exhibits traits of an asteroid too. And it doesn't have an attachment to any star system, so we don't know where in space it originates from. In 2017, it passed by the Earth at a distance of 41 million kilometers. Now, while we were safe from impact on that occasion, it could have resulted in a lot of destruction. If this interstellar guest crashed into Earth, darkness would cover our planet. And if the dust and debris stayed in our atmosphere for a long time, it would kill many plants, animals, and humans that depend on the sun. Bennu. Bennu is not only an asteroid you should worry about, it's the asteroid you should worry about. It has a 1 in 1,700 chance of colliding with Earth in September of the year 2182. At only half a kilometer wide, it's relatively small, but remember how significant the Chelyabinsk impact was? Yeah, with that in mind, you might be a little nervous when it makes a close approach to Earth every 6 years. Shoemaker-Levy 9. This next comet doesn't have any chance of hitting Earth. That's because it already collided with Jupiter in 1994. But you could imagine the destruction this 1.5 to 2 kilometer wide comet would have caused on our home turf. It broke into 20 pieces as a result of Jupiter's gravity. The collisions from these fragments were so powerful that they were similar to the detonations of about 300 million atomic bombs. Plumes of debris shot as high as 2,000 to 3,000 kilometers, and the atmosphere heated to scorching temperatures of 30,000 to 40,000 degrees. You must be pretty relieved that Shoemaker-Levy 9 never hit us. Ceres. Last, but far from the least, is an asteroid so big it's technically classified as a dwarf planet. Ceres is the largest object in the asteroid belt. It makes up 25% of the belt's total mass. The radius of Ceres is 476 kilometers. That makes it over 60 times larger than our ancient friend Chicxulub. If Ceres collided with Earth, there wouldn't just be devastation. There would be no Earth. The size of Ceres alone would block out the sun as it approached. And then, the impact would remove 10 kilometers of the Earth's crust. Hypersonic shockwaves would ripple across the globe. Everything in its path would be incinerated and leveled. Nothing would stand a chance of surviving. Our planet would essentially turn into a glowing ball of fire and melted rock. If by some miracle or secret underground bunker you survived, well, you wouldn't last long. Soot in the atmosphere would result in something like a nuclear winter. The sun's core is shrinking. But as its core shrinks, the sun itself grows larger. And it will continue to grow until one day it engulfs the Earth. How long can you survive? What will happen to the oceans? And will other planets be affected? This is What If, and here's what would happen if the sun swallowed the Earth. Every 1 billion years, the sun becomes 10% hotter. But here on What If, we're going to take billions of years and condense the action into 1 month. Get ready, because we're going to be moving really fast this time. Instead of 1 billion years, it would only take 4 days for the sun to become 10% hotter. This means you'll see the Earth engulfed by the sun in just 1 month. That is, if you're still around to witness the final event. On day 1, you'd be blissfully unaware of the tragedy about to befall Earth. Maybe it's a little hotter, but that's just weather. It happens. But by day 4, space agencies across the globe would be sounding the alarm bells. By this time, the sun would be about 10% brighter and hotter. And while 10% doesn't sound like a lot, it will be the beginning of the end for us. As the sun heats up, more and more water from Earth's surface will evaporate into the atmosphere. This will increase the greenhouse gas effect, causing global temperatures to skyrocket. All of a sudden, it will become very humid and very hot. But the sun's high-energy light would bombard the atmosphere, splitting those water molecules into hydrogen and oxygen. Earth will begin to lose its water, and you won't be able to escape the lethal radiation on Earth's surface. If you want to survive, you'll have to go deep underground. But even under a protective layer of Earth's soil, you won't be safe for long. By day 16, the sun would be almost 40% brighter. Our planet's oceans will boil, and there won't be any moisture left in the atmosphere. The beautiful, lush Earth that you grew up on will become a hot, dry, barren rock. Around day 20, the sun would run out of hydrogen, so instead, it will start to burn helium in its core. The sun is now a red giant star and would expand rapidly while losing its mass. The sun's gravitational pull on Earth would be weakened, and our planet would begin to drift away from the expanding sun. But not far enough. According to researchers Klaus Peter Schroeder and Robert C. Smith, the Earth would only have moved about 0.0002 astronomical units. An astronomical unit is the distance between Earth and the Sun. While Earth is moving away from the encroaching Sun, the red giant would grow up to 1.2 astronomical units in radius. The Sun would be larger than Earth's orbit. It would swallow the planet whole. Once it's inside the Sun's atmosphere, Earth would collide with particles of gas and spiral inward. And Earth wouldn't be the only casualty of the expanding Sun. Mercury and Venus would be vaporized. The rings of Saturn would melt. Pluto would become much warmer. And if there is a liquid surface and a thick atmosphere on this distant dwarf planet, it might even become inhabitable. Unfortunately, 30 days doesn't give the human race enough time to prepare for such a catastrophic event.
Hey, speaking of expanding stars, you like my hoodie? It's a nebula, the gas and dust thrown out by the explosion of a dying star. You can get one of your own from our online merch store. Oh, you didn't know? Yeah, check out the What If store at shop.underknown.com. You can get this sweatshirt, this coffee mug, a copy of our book, The What If 100, hats, hoodies, stickers. We got it all. Okay, this next one gives me the chills. Literally.
Overnight, our planet has gone from a pale blue dot to a glistening white snow globe. Stretches of Earth have become frozen wastelands that are completely inhospitable, and billions of people have been left unprepared for life below freezing. What changes would our planet undergo? What could we do to combat this global freezing? And would humanity be stuck on a giant, irreversible snowball? This is What If, and here's what would happen if the Earth froze overnight. Earth has experienced several ice ages. During these periods, ice sheets pulse outward from the poles and then retract. But 3 of these freezes, between 580 and 750 million years ago, had such an extreme effect that the ice didn't retract for millions of years. These are known as snowball events. Temperatures reached minus 50 degrees Celsius, and the ice and snow reflected light into space. As more heat was reflected rather than absorbed by the planet, the temperature kept dropping. If you could have seen Earth from space back then, it would have looked like a glistening white ball. Eventually, the Earth thawed. Otherwise you wouldn't be here watching this video, but if everything froze back again overnight, could you survive? Okay, let's start by looking at what new kind of planet you'd be stepping onto. Ice sheets 1 kilometer high would cover the Earth. Even in the tropics, the ice would be as thick as 10 meters. Most of the oceans would be covered in ice. Only near the equator or areas with lots of geothermal heat could liquid water still exist near the surface. Everything would be frigid. It would be so cold that most of life on Earth wouldn't be able to survive, especially humans. People living in cold climates would have warm clothing, but this sudden freeze would be life or death for billions. Imagine living somewhere like Belize, Namibia, or parts of Australia where the temperature never drops below 15 degrees Celsius. If you lived in those areas, you'd be at risk of death from exposure to the cold. The same would be true in many other parts of the world, especially for the poor and homeless or those with inadequate access to housing. All power and energy systems would be disrupted, and with no electricity, billions of people wouldn't have heating. Industries would grind to a halt. Even agriculture or livestock cultivation would be nearly impossible. Humans would need to band together to conserve food, energy, and other supplies. You would be ready for living on a giant snowball if you were a scientist based on an Arctic research station. At Amundsen Scott Station in Antarctica, the average temperature is minus 82.8 degrees Celsius. Scientists near the South Pole live in shelters built to withstand the cold and ice. Some even have gyms, greenhouses, a movie room, and a sauna. Life in a shelter, though, would be very confined. You would only go outside for specific tasks. To venture outdoors, you would need layers, a lot of layers. Scientists at these stations wear nearly 9 kilograms of clothing. It takes them about 10 minutes to get dressed. Any exposed skin could be frostbitten in less than 5 minutes. This deep freeze would also make the Earth incredibly dry, as all precipitation would turn to snow or ice. That dry air could make you feel dizzy. You would need to constantly thaw snow for water to drink. And the only way to get around would be with a snowmobile. Or if you're looking for a little recreation, you could try to master kite surfing on snow dunes. But be careful, in Earth's lower latitudes there would be howling winds. This would be another extreme element making life difficult. Researchers still don't know how the Earth thawed from these previous snowball events. Unfortunately, if we wanted to reverse the freeze, we might have to change our thinking about greenhouse gases and global warming. We would need to pump the atmosphere with carbon dioxide and methane. That means releasing pure gas or burning even more fossil fuels. Since its formation, the Earth has been revolving west to east on its axis. If one day our planet started rotating in the opposite direction, it would no longer be the Earth as we know it. In what ways would a clockwise rotation change the Earth? And why would you end up living in a desert? This is What If, and here's what would happen if the Earth started spinning backwards. You don't notice it, but our planet spins pretty fast, 460 meters per second as measured at the equator. A sudden change of direction would cause disastrous winds and massive waves. Together, these abnormal weather conditions would wipe out nearly everything above the ground. Let's just skip over this destroying transition. Imagine our planet reversed its direction billions of years ago. You'd see the sun and the moon rise in the west and set in the east. And you'd never believe that the Sahara could be a desert. How different would our planet turn out to be? Short answer, the reversed spin would make Earth much greener. Long answer, this new rotation would change winds and ocean currents, and that would shift the planet's climate entirely. Oceans work as a global climate control, distributing the sun's heat all over the Earth. They divert moisture from the driest, hottest badlands and carry rainfall to thorny jungles. If the Earth reversed its rotation, one very important climate-driving current would disappear from the Atlantic Ocean. Instead, a different current would surface in the Pacific and become responsible for distributing heat around the globe. This new current would make the deserts retreat from Africa and Eurasia. You'd have to go to the other side of the planet to do some quad biking on the Golden Landscape. More specifically, to Brazil. The US would also get very arid in the south. But none of the new barrens would be anywhere close to how dry the Sahara Desert is now. There'd be much more vegetation covering the planet. Hey, that's more oxygen for all of us. But those living in Western Europe would be in for a shock. The Pacific Current would push a lot of cold water that way, bringing freezing winters to the region. Russia, on the other hand, would warm up and take a break from being the coldest country on Earth. Life on the reverse spinning Earth would be different too. In the oceans, cyanobacteria would dominate over other phytoplankton species. Billions of years ago, the oxygen-pumping cyanobacteria invented photosynthesis and transformed our planet's atmosphere.
Yeah, I feel like the extra vegetation, though, would be feeding more animals and creating more methane, if you know what I mean. Maybe that could counteract the increase in oxygen. Hopefully we'll never have to find out. Okay, thanks for joining us on this epic expedition exploring every element of Earth's eventual endgame. Hope you enjoyed. We'll be back soon with another What If? Hey everyone, welcome to What If? We're glad to have you with us here today. On today's episode, well, it's a fun one, but it's a bit of a marathon of despair. We're going to take you through the top 10 ways that life on Earth could come to an end. But don't worry, none of them are going to happen to us. And none of them will be fun, but rest assured, you and I will have some fun learning about them. That's what we do here. So first off, what would happen if Earth pulled the emergency brake? Would we all just get a bad case of whiplash? You wish.
Hang on, because we're about to screech.